Hi all, I'm Martin, I'm from Polymath, and I'll tell you a bit about our company today. But before I do, just want to say we are very excited to launch confidential assets. We think it's going to make a significant contribution to the community. But yes, it is an evolution, and I've been involved with blockchain since about 2017, and it's come a long way since then. And I think at certain points there are tipping points along the way which really help define where the technology is going. I don't think anyone would have realized just where things are, where we are today. And I think tokenization and blockchain is kind of a real synergistic partnership. But it wasn't always that way. I was quite curious when one of the presenters previously suggested we do use blockchain for data and for other use cases. Now, I've been around this business for a while, and initially I was involved with a more crypto sort of company. We did try our hand at various other technologies. Blockchain was often a technology looking for a problem to solve. And finding those problems has been hard. So for example, a few years ago, I was involved with legal tech, and we developed some fantastic technology to do smart legal contracts on-chain. So these are legally enforceable smart contracts. I hate the term smart contracts by itself. They're rarely smart, and they're certainly not contracts. And so we went to law firms and said, look what we can do. And I go, that's fantastic. Who else is doing it? We said, no one. You can be the first. And they just went, oh, okay. And so the takeaway there is that in order for a technology to be adopted, it has to solve a problem by 10x or 20x or 100x. It can't just be a 1.5x improvement. And the law firm saw this as being, yeah, that's great, but I'm not going to change my entire cultural ecosystem to adopt this technology, which is why law firms are still embedded in Microsoft Word and email. However, there was one industry that did embrace blockchain, it was free for all, unregulated, and clearly there were some ups and downs, very much a roller coaster ride. And the great thing about this industry was that it really did prove the technology. If there was ever a group of people, if they could find a way to take advantage or otherwise, how should we say, compromise the technology, this is the industry that do it, right? And so it's been great in terms of that, not so great in terms of some other people. There's no regulation, so a lot of people obviously got their fingers burnt. I know this may upset some of my more sort of decentralized maximalist friends, but that's the reality. So the Polymath journey has been similarly evolutionary. And I've only been with the company since December last year. So I feel like a Johnny-come-lately coming in at the last minute to go, woohoo, look what we've done. But they started in 2017. And by the way, I'm going to shamelessly plug my company here for two reasons. One, we're a sponsor of the event. And two, because this company has some great tech, which I think can make a real contribution. And until recently, I'd never even heard of it. And so the thing with Polymath is when they started in 2017, they started with the idea of enabling regulated assets and securities to be traded on a blockchain. This is 2017. Who was thinking about regulated securities in 2017? That was the peak of the ICO boom. I remember being in a company in 2017, we raised like $4 or $5 million in 24 hours on an ICO. I thought, this is crazy. And it was not regulated, by the way. And so in 2018, Polymath actually were jointly authored the ERC 1400 standard, which was a way to trade securities on the Ethereum blockchain in a regulatory-friendly way. And they were big advocates of that. And there are other standards along the way. The great thing about standards is there's so many of them. And but then in 2020, they realized that, at least at that time, and I haven't played with Ethereum for a little while now, so I don't want to misrepresent them, but at that time, they realized that the general purpose blockchains just couldn't cut the mustard when it came to managing regulated securities on a blockchain. And so they published the Polymesh white paper. So Polymesh was a database, a blockchain network that is purpose-built for regulated securities. And why is that important? The fundamental issue with general purpose blockchains is that although we have the standard, that standard has to be coded into a smart contract, and that smart contract has to be created for whatever application you want to tokenize or regulate. And so you end up with umpteen, hundreds, thousands or whatever of these smart contracts. What Polymesh has done is by taking the standard and effectively coding it into the protocol layer, then you don't have to worry about any of that. And that's good news because, as I think Lee said before, about auditing and getting your contracts tested to make sure that they don't have any challenges with them, we've done all that. So we're a SOC 2 compliant company, and so you can still create smart contracts on the Polymesh network, but you have access to all the underlying infrastructure that supports regulated securities. Things like settlement, affirmations, attestations, that kind of stuff. Now, the Polymesh platform is really great for institutions, and so from 2021, when we launched mainnet, we worked hard to get a number of institutions to use our platform. You can't just interact with the Polymesh network without some sort of application sitting on top of it. But in 2023, the company launched the Polymath Capital Platform, which is our kind of marquee application, which pretty much shows all the capabilities of the platform. It is very much a Web 2.0 experience. So unlike other applications that are built on other blockchains, where you have to handle a private key and understand what this language is and that kind of stuff, this platform is designed for end users who don't care about the blockchain. They don't even want to know what it is. They don't have to worry about their private key and that kind of stuff. This is a platform that my dad could use, right? And so it has AML, KYC built into it. It has the payment rails. It has integrations into signing platforms, so people can actually sign documents to say, yes, I agree that I've watched this disclosure, I've read this disclosure, whatever. And so that platform is not an institutional platform. Institutions could use it, but they're not going to. They're going to integrate directly into the mesh itself. So the sort of people we have on the Polymath Capital platform are your mid-market people, your real estate agents, property developers. We have, what else we have? We have a heap of a whole range of anything that you can legally own and legally trade, then you can tokenize on this platform in any jurisdiction, anywhere, anytime. Now the caveat here is that this is a technology and it is a platform. We are not ourselves regulated, and so we work with partner organizations, broker-dealers, transfer agents, and with ATSs, those sort of people, to actually provide the regulatory rails for our clients. And so it is a journey. Regulation is designed to slow you down. And so we have situations at the moment where when a client tokenizes an asset, they need a broker-dealer to verify that before they can move on to the next phase. If someone actually wants to invest in an asset, that be checked by a broker-dealer to ensure that they are eligible to participate in that particular offering. So as regulation becomes more trusting of the technology, then this will become easier, but that's how we operate today. However, in 2024, we realized that this public permission blockchain, as good as it is, was never going to be used by institutions, and the reason for that was because of privacy. The strength and the weakness of blockchain is the fact it is transparent. And so in 2024, Polymesh engaged a highly talented and good-looking PhD student here at Edinburgh, Amir. Do you want to stand up, Amir, and just say hello? So Dr. Amir Sarantia is actually Edinburgh-based, and so the company engaged him in 2024 to figure out how to actually have data be encrypted on a blockchain where traditionally that's been incredibly hard to do because of the whole need for transparency. And so they spent 2 years. 2 years, Amir's worked with our in-house cryptographers, and they have built what we call confidential assets. It is zero-knowledge proofs on-chain, and it does enable complete obfuscation of all the sort of typical data that you don't want to have showing off to clients, such as your, obviously the sender, the receiver, the amounts, the balances. There's a heap of metadata around each transaction which you don't want to have disclosed. So privacy. We think that privacy is the next sort of tipping point or pivot point in this journey. So, as I said before, blockchain's strength is also the weakness. Because of transparency, it means that anyone can see what's going on at any one time. Immutability means that no one can actually tamper with it. Public verification means you're not relying on a centralized source to confirm a transaction. It's all decentralized. And so in the middle is where the magic happens. So zero-knowledge proofs sit here. Now, there was talk about jargon before. Who here has heard of zero-knowledge proofs? Who here knows what they do? Ooh. Oh, you do, that's good. So zero-knowledge proofs, for those who don't know, it is a way to encrypt data, which I also don't understand, which enables you to prove that you have something without actually revealing the data itself. So a good example of that, if you're a bouncer at a nightclub and someone has to prove that they're over 18, that person needs to prove they're over 18, but they do that today by showing their driver's license, which means they're disclosing their name, address, date of birth, and that kind of stuff. Whereas a zero-knowledge proof would be more along the lines of, I have a digital certificate that says I'm over 18. Okay. And, but the good news is there's PhD papers to read if you want to understand the detail, right? So our zero-knowledge proof is based on we call it DART, Decentralized Anonymous Regulatory-Friendly Tokenization. So Amir and his colleagues worked on that initially. And then PDART is the Polymesh implementation of our zero-knowledge proofs. Now, this information is all publicly available, so we encourage people who are interested in this to have a read. The links are there if you want to check them out. But clearly, a lot of thought and effort and time and energy has gone into this. And this is just an example of the way that this is okay. Last year, I had the privilege and honour of working with the Digital Trust Centre of Excellence here in Scotland, along with the Bank of England and the Bank of International Settlements. And the question they were asking was, how could the Bank of International Settlements do settlements on a network, blockchain, which they do not control? And so we went through a process. In fact, James Bell, we used to be at Nethermind, is here today, James. We worked on this as part of that. And this was kind of the solution we came up with. So what we did is we targeted Ethereum as the layer 1 because we wanted to make sure that that was the gold standard in terms of immutable blockchains. But the challenge with Ethereum is, at that time at least, was that it's expensive and it's slow and it's not private. And so we created a layer 2 blockchain which did all the heavy lifting in terms of the transactions, and then we'd roll up all those transactions together, do a zero-knowledge proof on those, and then submit that to the blockchain. And so that meant that we could reduce costs and have it so that the proofs were done off-chain. And then when we could then verify those proofs were okay by checking the proof against the data on-chain, and everyone's happy. It works, it's fine, it's good, it's not a bad way of doing it, but this is how we would have done it on Polymesh. Everything is on-chain now. So all our identity and permission rules are there, compliance and transfer rules, confidentiality, etc. And settlement and finality, of course, are very important when it comes to these things too, right? So we're very proud of our tech. We think that, this could make a real difference. This code is all open source, so you can go to our GitHub repos and check it out. Yeah, we welcome you to do that. So what problem, getting back to my original point about blockchain needing to have a problem to solve, what problem is it solving? Well, the obvious one is secondary trading. So we have confidential secondary trading so that institutions can trade with other institutions in a way which allows them to not disclose their trading positions and not disclose their client data and basically keep things secret. The other problem we're solving is private settlement between institutions. What we're noticing is that a lot of companies have built quite complicated blockchains inside their own firewalls, inside their own silos, and that's great, and they've done that because they don't want to expose that blockchain or whatever it is to the outside world, and rightly so. Now they have all this value on chain inside their silo, and they want to be able to interact with another institution. How do they do that? Well, they can't go to the public blockchain because that would expose their positions, and so the way to do that is to build bridges. And bridges can be fraught. And if you want to do it with more than one institution, you can build more than one bridge. And so we have a client in London we're talking to at the moment who are thinking about doing this, whereby they have, in their case, a Hyperledger Besu blockchain inside their own organization, and they can then wrap that token, put it onto the Polymesh network, and then transfer that to another institution in another part of the world. All completely confidential. So yeah. Oh, and that's right. The other thing that the other issue, that sort of the downside of encryption, is that no one can see what's inside. And so we want to make sure that the regulators or the auditors can actually see what's going on without seeing what's going on. And so our platform, our confidential assets, allows the issuer to insert the ability for auditors to log in and verify through the proof system that everything complies with the regulations, which I think is pretty cool. Now, we're not the only game in town. We have a number of competitors. We have the privacy first protocols, and they're fine, but they don't obviously deal with compliance very well. And we have the compliance first protocols, which coincidentally don't deal with privacy very well. That will probably change over time, but at the moment we do both very well. So now that we have got, and we're going live with confidential assets on a testnet next week. So if anyone wants to try it out, play with it, get under the hood, then feel free to reach out to us and we'll happily give you access to the system and you can play with it. The next cab off the rank is quantum. We have a real challenge here that practical quantum attacks are no longer theoretical. They will be coming, and so we're now looking at quantum, post-quantum encryption, at creating a PDART quantum resistant version. And The challenge of quantum is it's going to be even bigger keys, even bigger encryption algorithms. So speed, we spend a lot of time optimizing PDART to work really fast on our chain, and by adding another layer of encryption for quantum, it's going to make it even slower. So we might have to add hardware acceleration. Watch this space. You can keep it. We'll keep you posted. So privacy is in our DNA. We've been around since 2017. We're a layer 1 blockchain. We are niche. We don't have a huge amount of volume. We don't have a lot of meme coins on our chain for some reason. And thank you for listening.